So, friends, good morning and welcome to this lecture series of Geomorphology. Today, we will discuss about this coastal geomorphology and landforms. So, if you remember our last class, we are talking something about this coastal geomorphology, and we concluded that the coast, the geomorphology is not only the present day geomorphology that exists or which is going on in front of us. At the coast changed many times from the geological past to recent. So, those changes by those agents, so landforms characteristics of that particular environment or particular agent, they are remaining and along this coastal zone as relict structures. And the present day coast also some new landforms are being created by the wave action, by the tides, by the currents, by the rivers and particularly the aeolian system, the winds, and some of these landforms they are created by some organisms. So, the present day coastal geomorphology is a mixture or the complex combination of all those factors from the geological past to present. For example, suppose we go to this early Holocene when there was a glaciation or this late Pleistocene when there was a glaciation, most of this water they were in a frigid form and the sea level was much below than the present one. So, at that time as there was a gap of this sedimentation and the sink. So, that means this transportation or the river process, river mouth, the position of the river mouth was this level and the sink was at that level. So, that means the river mouth started eroding. So, that is why we found some of the gorge type of structures. Similarly, during glaciation there was glacier movement through some valleys and there was deep erosion and some of these erosional features they were also present in the present day oceans, particularly along these coastal parts. So, that means I want to say whatever the geomorphic features, whatever the structures we are looking at the present day coast, they are not the product of the present day processes only. Some of these processes or some of the landforms, they were formed by some other agents in the geological past due to climate change, due to tectonism, but these are remaining there as a relict landforms. So, we are talking something about the geomorphological agents we are working there. We have forgot about talking about the tectonic process. In the past also geological past, even if in the present, these coasts mostly affected by the tectonic processes. For example, if we are confining ourselves along this Indian coast itself, the east coast they are characterized by some buried basement faults, very long running basement faults are there. Some of the basement faults they are active. As a result, the coast has been segmented into different parts with the host and gravens. However, these host and gravens, the irregularities, they are covered by these present day sediments. So, that is why it is looking like a plain area, but due to this fault activity, this faulting, these tectonic activities, those area contains some of these landforms which are characteristics of that tectonic process. So, that means along this coast we will get tectonic landform, aeolian landform, glacial landforms, fluvial landforms and marine landforms. So, that means biological landforms, some of the landforms are created by human activities, anthropological landforms. So, that means landforms are many, but the processes are also many. So, we have to distinguish which type of process landforms they are formed by which type of process and which are the relict landforms which are formed during past processes and which are the present landform which are occurring nowadays. So, this is the theme of this class today. So, relict and active landforms are intimately mixed and frequently confused. For example, if you confine ourselves here in this satellite imagery, you see there are ridges, see there are ridges similarly here and similarly this side also. These ridges are parallel to present day coast. These ridges are the Aeolian ridges, they were formed in geological past. Similarly, present day if you see here, these are the ridges and present day coast is here, and we are getting the ridges or this coastal activity some kilometer towards the land. So, these are the relict features, and present day river mouths, they were modified during this Pleistocene glaciations. So, whatever the river mouth structure or river mouth characteristics nowadays, they were once upon modified during this Pleistocene glaciation time, and they are continuously modifying at the present day by the river processes. So, these are the landforms, they are called relict landforms, and if we date those relict landforms, we can say when these relict landforms were formed. Okay. Subaerial processes interfere with the and contribute to coastal geomorphic changes as well. Subaerial processes. So, whenever we say about the coastal geomorphology, we are not only confining ourselves around the marine activities or the ocean activity along the coast. Subaerial processes like wind, like rivers, glaciers, they also contribute or contributed in geological past in modifying this type of coastal structures or coastal plains. So, the coastal ocean including estuaries is a zone of enormous biological activities. If you see the estuaries or if you see these evidences from here, here there was an estuary existing, here there was a estuary existing, here there was a estuary existing, and these black areas along this coastal plain, which is nowadays it is away from the coast and is confined within the main land, they were the estuaries of geological past. So, that means it is indicating once upon a geological past, this coast was somewhere here or the coast area was somewhere here and these estuaries were formed. And those estuaries are very much fertile for this product of biogenic material, and these organic activities, they create their own landforms. So, we have relict landforms, we have biological landforms, we have Aeolian landforms, these marine landforms, river landforms, glacial landforms. So, that means this coastal zone if you confine, you will find many of these agents, geomorphic agents, they have worked in geological past, and some of these agents they are working nowadays, particularly the ocean and these Aeolian activities or the wind. So, if you remember when we are talking something about the Aeolian activities, mostly these parabolic dunes, the Aeolianites, they are confined along the coast zone. In warm tropical ocean, organisms built major shallow water or coastal landforms. So, where at what type of environment we are dealing with? If it is cold environment, the organic product will be less, but if it is warm environment, the organics presence will be more. So, more organics presence, more will they modify and more will they create these organic structures. So, in particularly the warm water environments, to those coasts which are along this warm water environment or warm oceanic currents are flowing along this coast. So, those part are more vulnerable for organic products, and mostly the organic landforms they are confined along these warm tropical oceans. Entire island archipelagos are merged coral reefs uplifted by tectonic movement of relative times higher quaternary sea level. These coral reefs they are very much sensitive to this warm water environment. So, if you elaborate it this coral reef, you may say they create a particular type of structure like the fringing reef, barrier reef, atolls, and these are partly contributed by the tectonics. With this narrow almost linear coastal zone, a complex range of landforms are eroded and built continuously. Organisms evolve special forms of landforms and human activities also focused. So, that means this is a narrow zone about 40-50 kilometers width and somewhere it is 100 kilometer width. That zone is confined or highly focused with different geomorphic agents, organisms, human activities. So, that is why the coastal landforms are more important landforms to study. Now, after coast we have to go to this shore zone environment. So, that means up to now we are talking about these landforms which are near to the shore. So, now let us discuss about this shore zone processes and landforms. So, what is a shore zone process? First of all we should describe what is a shoreline. So, shoreline it is a line of demarcation between land and water. So, here if you see this is the shoreline, but this shoreline is not a fixed line here. So, during high tide the shoreline moves in this way, due to low tide the shoreline moves this way. So, that is why it is called shore zone rather than only shore. So, shore zone it is a zone which is defined by this or bounded by this high tide and low tide marks. So, that means this shore zone it is continuously affected by wave action. You see here the waves they are continuously eroding, depositing, transporting this material from the here. So, the shore zone is a very dynamic geomorphic landform which changes even if within day. So, during high tide this whatever the landforms formed during the that means other time during high time it will change and will move sediment towards land, and during low tide those sediments that will be again moved back towards the ocean. So, dynamic landform every say 7 hours, 6 hours or even within day the landform changes. It fluctuates from moment to moment influenced by waves and tides. So, it is not a fixed zone or fixed line, it fluctuates. The shore zone or simply it can be called shore is the zone affected by wave action. So, here this is the shore zone and mostly it is the wave action, it is modifying the shores. The coastal shore zone is conveniently subdivided into different segments. So, depending upon the processes involved, depending upon the dominance of these processes, the shore zone has been divided into different segments. First is the offshore, the shallow bottom seaward of these breaking waves. So, what is offshore? Off means away. So, offshore it is away from the shore towards the ocean. So, this is the zone, it is the shallow water zone or the bottom zone where it breaks the sea waves. When the wave is coming from this deep ocean towards the coast, this is a zone which breaks it. So, breaks it means its amplitude increases, wavelength decreases. So, this breaker this is called also breaker zone. So, this breaker zone around somewhat kilometers away from this shore zone, and it breaks the waves into different forms. So, that is called offshore. Then near shore between the breaker zone and the low tide level. Breaker zone is there away from some kilometers away, and the low tide region, that means when there is low tide. So, the water level decreases. So, that zone which is confined between the low tide region and that breaker zone, that is called near shore region. Then foreshore, fore means front, foreshore which extends from the low tide level to the limit of high tide level. So, during high tide and during low tide, this area it is called foreshore region. So, it is sometimes some other way it is called littoral zone also. So, the area or the zone between the high tide and low tide region, that is called foreshore. Then backshore, backshore forms the limit of the recent or frequent storm wave landward to the base of this cliff, dune and vegetated ridges. If you see in this figure, all those zones has been marked here. This is the backshore as we are talking now. Backshore is the high tide or this storm activities is there, the maximum water level up to which the water can come during storm. Then it is the cliff or the vegetated part of this coast. So, this region it is called backshore. And here this is the wave breaker, this is the breaker zone, here this is the shallow water you see it is coming and gradually the depth suddenly it is increasing here. So, this is the breaker zone. So, the breaker zone and the shore, this is called offshore. See, this is the mean sea level here, this is the mean sea level attached and this is high tide level, this is low tide level. So, this region from here to here, this is called so that is called breaker zone. And similarly, from high tide to low tide, this is littoral zone or it is other way it is called foreshore region. So, these are the subdivisions and all these subdivisions are based on the nature of the wave activity. So, all these subdivisions, this wave activity here is different from the wave activity here, is different from the wave activity here, and the main work of this zone or this called breaker zone here, this total characteristics of wave which is coming from this to this direction, the total characteristics changes from here and those characteristics change is responsible for weathering and erosion of this coast, their transportation and deposition. Now, if we confine energy level at this coast and we know all these geomorphic agents, they are energized by sun and the sun energy it is divided into different segments and finally subdivided into again either by wind, by river, there are glaciers like that. So, here wind waves is the most of this energy expended in the shore zone is transmitted there by wind generation waves or the water surface. So, here wind is creating waves, there is a friction, there is a shearing of wind and this water surface, open water surface on the ocean body and is creating waves and that wave is coming and interacting along the shore. Due to this interaction of these waves, this system either this deposit or transport or they erode this material and finally, the coastal geomorphology changes along the shore zone. In an area of strong winds and storminess over the ocean, the water surface is thrown into a confused mass of waves that is intersects the peak and troughs. So, that means waves if you are creating these waves. So, these waves have some it is the trough, it is the trough and it is the crest and how much height the wave will attain, what should be the wavelength of a wavelength. So, that is depends upon the wind speed, that depends upon the duration for which this wind is interacting with the ocean surface and the size of the wave that is responsible what type of landforms we are going to get or along this coast zone. So, the wave nature that defines the coast geomorphology. So, the height of wave generated by the wind depends upon the wind speed, the duration of the wind from one direction and the phase of the length of the water. It is very important, if you see the phase or length of this water surface over which the wind blows. So, if you remember when we are talking about this aeolian processes, we are talking about this critical size of the sand that it will promote the formation of dune and it is the 4 to 6 meter if we have sand that is a spread area 4 to 6 meter and continuous sand supply is there, then we are creating a sand dune. Similarly, the fetch means it is the length of water surface over which the wind blows. If the length of water surface is more, that means wind has sufficient space to interact, and finally, it will create these waves. Otherwise, the lakes are there are ponds are there, though wind is blowing, we are not getting waves, because this is the question of fetch. So, fetch is the main factor here which defines what should be the size of this wave, what should be the height of this wave, okay. And size and height, that will affect our coastal geomorphology. This either erosion or deposition, how much erosion will be there, how much deposition will be there, that depends upon the size of the wave. And finally, it is the fetch which decides what should be the size of the wave. So, it is the role of fetch in wave generation explains why even large lakes never have wave heights comparable to those measured in the open ocean. So, open ocean, we have vast open area. So, wind is free to move and free to interact. So, that means a vast area is affected by the wind activity, and a continuous wind supply along this vast area, it creates wave, and this wave generates from a place, it transforms, it transmits towards the coast, towards all directions, and transmits towards the coast, and once it is coming to the breaker zone, that here this nature of the wave changes. So, once it was created as a high wavelength low amplitude wave, but once it is coming to the breaker zone, it is coming to low wavelength and high amplitude waves, and finally it breaks down. Radiating outward from the generation area of the sea, waves with longest wavelength advance most rapidly, and those small wavelengths trail behind. So, here if you see, this is the fetch and this is the wind blowing here in this direction. First it starts with micro ripples, then the ripple size increases, then it chops, then finally it is a fully developed wave. So, this fully developed wave, it migrates in this way. So, once it reaches to the breaker zone, it breaks, and this nature, whatever the wave height and this wave size is here, at the breaker zone it changes. So, steep waves with large height length ratio decay rapidly, but the long wave radiate for thousands of kilometers across the ocean with little energy loss. So, it is very important to understand here, those long wavelengths, they travel fast and they can travel hemispheric distance. So, that is why it is said that the energy for wave erosion in that area, not necessarily this energy will be supplied from kilometers away, it may be the other hemisphere. So, this wavelength, if it is so high wavelength, they can travel to the other hemisphere even thousands of kilometers, and it will interact with the coast here. So, that means I want to say here, this coastal region is the combination of many processes, and mostly the wave which is currently modifying these coastal processes and coastal plain, but that does not mean the coastal plain is the only product of this present day activity. The coastal plain, whatever the geomorphology, geology and the landforms are there, they are the combination of many processes in the geological past and including the present, and the past geomorphic processes or geomorphic landforms, they are called the relict landforms, and some of the relict landforms, they are constantly being modified by the present day processes, and the ultimate product is the coastal products. So, thank you very much, thank you, and we will meet in the next class.